So we're going to start with the Pythagorean theorem. Okay, so the Pythagorean theorem is a squared plus b squared equals c squared. We talked about that a lot during that unit. And we're going to look at solving for missing sides. And we're going to look at a baseball diamond. I'm going to read you the problem. It says a baseball diamond is a square with sides measuring 90 feet. What is the straight line distance across the diamond from first base to third base? So the first thing I would suggest doing is drawing a picture. So you draw a picture of a baseball diamond. Hopefully you can draw a little bit better than me. Okay, we label each side 90 feet. And then each corner of the diamond is a right angle. And it wants to know the straight line distance across the diamond from first base to third base. So first base to third base, right across there, is what we want to know. It ends up making a right triangle. And we have to determine what we're solving for. Are we going to solve for A, B, or C? The two parts where the lines come together and make the right angle are our legs, and they are A and B, so we're solving for C. So A squared plus B squared equals C squared. 90 squared plus 90 squared equals C squared. 8100 plus 8100 equals C squared. We add these two together over here and get 16,200 equals C squared. We have not solved for C yet because this is squared, so the opposite of a square is the square root, so we square root both sides. The square root of C squared is C. The square root of 16,200 is, when you round it, 127.3 feet. Okay? Then let's do this next one. We have a picture of a right triangle. The side across from the right angle is 37 feet. One of the sides that makes the right angle is 35 feet. Okay? So I'm going to say this is A, this is B, and this is C. Okay? So A squared plus B squared equals C squared. We said that A was going to be 35. B is the X. And C is 37. And we bring down our squares. 35 squared is 1,225 plus X squared equals 37 squared is 1369. To solve, or to get x squared by itself, we've got to get rid of this 1225. So it's positive, so the opposite is a negative. Negative 1225. Negative 1225. These cancel. We're left with x squared equals 144. We haven't solved for x yet, so we have to square root both sides. X equals 12 feet. Okay, and we're going to talk quickly about 30, 60, 90 triangles to remind you of that relationship. A 30, 60, 90 triangle is part of an equilateral triangle. So I have an equilateral triangle drawn. We know that it's equilateral. All the sides are the same length, and all the angles are the same. They're marked with one tick mark. Okay, if I cut this in half, okay, I end up with the right angle down here at the bottom. This is still 60, and the angle at the top is half of 60, which is 30. So I'm going to redraw this over here. So up here we have 30 degrees, 60 degrees, and 90. This side was 6 meters, So the bottom side is now half of an equilateral triangle, which would be 3 meters. And then you should be able to solve for this. But we know, we've worked through this and found that this has a special relationship. And the special relationship is if the short leg is x, the hypotenuse is double that, so it is 2x, and the long leg is x square roots of 3. You guys remember that relationship? We talked about that. Okay. And then you would use that information to solve. So what is this length over here? This length over here, you would just take 3 and plug it in for the x. So the length over here, the long leg, would be 3 square roots of 3. Okay? Now we're going to look at finding the distance between points on a grid. I have 2 points labeled X and Y. The best way to do this is to turn them into a triangle. So you draw straight down and to the left, or sorry, right, and then you connect your dots. We have a right angle here. This is a right triangle. The long leg is 1, 2, 3, 4 units, and the short leg is 2 units. And then you would find the distance between them. So this would be A, this would be B, and we would solve for C. So A squared plus B squared equals C squared. 2 squared plus 4 squared equals C squared. This is 4. This is 16. So 20 equals C squared. We've got to square root both sides. So C equals 4.5 when we round it units. Now this last part, the converse of the Pythagorean theorem. Okay, the converse of the Pythagorean theorem is just when you look at the triangle. If a triangle has side lengths of A and B with the longest side of length C, then you would have A squared plus B squared equals C squared. So the converse of the Pythagorean theorem, you're going to use the Pythagorean theorem of a right triangle. So that was A squared plus B squared equals C squared. Okay, to become an acute triangle, okay, that is where it is a little bit different. And we talked about this in investigation 3 of looking for Pythagoras. Okay, an acute triangle was A squared plus B squared was greater than C squared, and an obtuse triangle was A squared plus B squared is less than C squared. And what these squares mean is the area. So we're looking at the areas and seeing if they equal C, or if their areas are equal to C, greater than C, or less than C. Now, the bell may ring. Do not go anywhere. Okay, we're going to work through these last 3 real quick. In this problem right here, the area here is 100, the area here is 36, and the area here is 144. So all we're going to do is add them together to see if they're equal. So area is 36 plus 100. Does that equal 144? 36 plus 100. Does that equal 144? 136 equal 134? No, it does not. So we put a slash through it. What type of triangle would that be? Is 136 greater than 144, or is it less than 144? It would be an obtuse because it's less than. So that would be an obtuse triangle. Down here, let's skip this one and go right to this one. So we're going to have to find the area. So A squared plus B squared equals C squared. 9 squared plus B squared, 40 squared equals 41 squared. B squared is, I'm going too fast. Slow down. 9 squared is 81. 40 squared is 1600, right? Equals 41 squared is 1681. We add these together. This is 1681. Does that equal 1681? Yes, so that is a right triangle.